My presentation for today is called Post-MVC-Age. And in this presentation, I will take a look at the component architecture. And component architecture is a new way to build applications. So first a little bit about myself. My name is Maarten Hus, and I'm a developer at Redux company called 42. And we mostly build Java and Angular applications. So this is the roadmap for today. What I want to do first is I want to take a look at the components themselves. And then I want to dive into the component architecture. And after that, I want to go over Redux and reactive programming, which are two advanced ways to power up your component architecture. So to start with components, what I want to do is I want to make a case study of a Google Maps component from the Polymer framework, just to see what components can do for us and what they're all about. So here's an example of a Google Maps component. Here you can see that there are 4 cities: San Francisco, Amsterdam, New York, Tokyo. There's this Google Map widget, and there's a map marker at the center of the city. And when you hover over it, you see information about a local sports team. But if we take a look at the San Francisco Google Map, let's take a look at the code behind that map, see how we can create that particular Google Map. And the code behind it is relatively simple and relatively small, and it's this. And as you can see, in the Google Polymer framework, you can create your own custom HTML elements. In this case, a Google Map element and a Google Map marker element. And to control the custom element, you give it, we assign it properties. In this case, the longitude and latitude, and that determines the center of the map. And to add a Google Map marker, we simply set the longitude and latitude, and we make it draggable, and we set it like so. This relatively few lines of code gives you a Google Map component. We can also listen to events, so we can send data into the component via its attributes. We can also listen to events of the component sends out by, in this case, adding event listeners. That's the Polymer way to do it. So that was a Google Maps component, but let's look at a component a little bit more abstractly to see what the characteristics behind those components are. And the first characteristic is that a component is isolated. This means that you can put multiple components, multiple instances of the same component on the same screen without them interfering with each other. So in the example we saw before, we had 4 Google Maps components, and they could be controlled separately without them interfering with each other. Oh. Another characteristic is that a component has very clear input and output semantics. And that means that the only way to manipulate a component is via the inputs that it provided for you. And the only way a component can manipulate the outside world is through very clearly defined output semantics. So in this case, the inputs are the longitude, latitude, and the output was the event listener that we added. Another characteristic is that a component is declarative. So we just all saw this Google Map component in action, and it was very declarative. It was very easy to, just by looking at the code, to figure out what the component was actually doing. And the final characteristic is that a component is composable. And what I mean by that is that you can take multiple smaller components, for example, a button component and an input component, and combine them to create a search component. So we can use components as Lego blocks to define components in terms of other components. And that's a very powerful mechanism. And all of these characteristics, they make components very easy to reason about. Because a component is isolated, when you see it on a page somewhere, you know what that component is going to do. And when you see it in the code somewhere, you're pretty sure what that component is going to do. And because a component has very clear input and output semantics, aka it does not manipulate the outside world, it's very easy to understand its place in your application. So to conclude, components are pretty awesome. But what we just saw was a component in isolation. So now the question is, how do we build apps using only components? So to demonstrate that, I've created a very simple to-do application in Angular 2.0. And everyone probably knows how this works. You can add a to-do, you can cross them off, and at the bottom there's a footer, and there you can toggle between the components state, the to-do state that you want to see. For example, if you press active, you only see the components you need to do, and when you click completed, you only see the to-dos that you've already done. So like I said, this application was built in Angular 2.0, and it was built from the following components. And I've represented this as a tree. And that's the funny thing about a component-based application, that it is actually a tree. Just like normal DOM elements would be on a page, they are also trees. So what we see here at the very top is the to-do application. And that's the so-called root component. It's either directly or indirectly the grandparent of all other components. And this is an example of the composability. So this entire application is basically one single app component. And on the right here we see this to-do list component, which has an n number of to-dos, which are currently on the screen. And we also have an add to-do component, which is basically an input element. When you click enter on it, it will add a new to-do. And we also have a toggle all component. And when you click that, you instantly check off all your to-dos. And on the left, we have the filters component, which represents the footer, which has 3 filter components, all active and completed. But if you take a look at this tree, or any tree which represents a component-based application, you might have the following questions, or at least I did. And the first question you might have is, where does the state live in this application? And by state, I mean, where are all the to-dos stored? Where is stored which filter is currently active? And the second question you might have is, how do these components communicate with each other? How do they do that? And to make that a little bit more concrete for this to-do example, we could ask the first question this way, instead of saying, where does the state live? Where do we put the current active filter? So if we take a look at our tree, we could say, let's put the current active filter in the filters component, because that's the place they all have in common. They have the same parent in common. But then you realize that the active filter is used inside the to-do list. And in that component, it is determined which filter to apply. But then you might argue to put the thing in the to-do application root component, because that's the common parent of all of these 2 components. So what I did, I put it in the to-do application, all the way at the top, but the answer is not very clear. So you can make the case for each of those 3 components, and it would probably be a valid case. So this is not a very satisfying answer, I know that, but later on in my presentation I'll show you a way to make this question a little bit easier to answer. But for now, it's not always very clear where the state should live inside of an application tree. So that brings us to the second question, how do components communicate? And we can ask that by asking ourselves, how do filters change? And like I said, I chose to put the filter all the way at the top in the to-do application. So when you click on completed all or active, in some way I need to communicate that all the way to the top, because that's where the data is stored. So what I need to do is I need to, when the completed is clicked, send it to its parent. And when filters has it, it needs to send it up one level to do application. So the thing is that a component cannot communicate to another component which is not directly related to it. So you can only go from the child to the parent, from the parent to the child. So that means that communication is a little bit of a hassle, because the more distance there is between the component in which you want to communicate with, for example, here we want to communicate from the blue component all the way to the red component, you can see that we first need to go all the way to the top and then all the way to the right. So basically, these two questions highlight two weaknesses of this architecture. So it's not always clear where the state goes, and communication between components that are not directly related to each other, that's a little bit of a hassle. So now we have seen components and we have seen two weaknesses. So now it's time to look at a way to mitigate those weaknesses. And in this case, that means taking a look at Redux. So what is Redux? Well, Redux is a library created by a guy called Dan Abramov, and it's the most popular implementation of an architecture called Flux. So what is this Flux thing? Well, Flux was invented at Facebook, and it's a way to do unidirectional data flow. And Flux is more of an idea, and Redux is an implementation of that idea. And since it's the most popular one, I've chosen to focus more on Redux instead. So what is the idea behind Flux and Redux? Well, the idea is that we still have our component tree, but we are going to put another concept next to that tree. And that concept is called the store. And what the store does is it provides all the state to the component tree. So we no longer store our state in components. We store every bit of state of this application in one single variable in the store. And whenever an action occurs, for example, we add a new to-do, we check a to-do, or we toggle all to-dos, or we check on a filter, an action is sent to the store, and that manipulates the store, and then we send the state to the component tree again. So if we look at it slightly differently, like this, you can see where the unidirectionality comes from. So the store provides a state to the component tree fires actions, the actions manipulate the store. And this will go around and round in a single loop, but always in one direction. That's why it's unidirectional. So Redux and Flux, they give us two very nice answers to our two questions. So the two answers are that all state simply lives in the store. So we no longer have to worry about where in our component tree we store state. And the second is that all events route to the store. So we no longer need to communicate between two components directly. We simply send all events to the store where the state is manipulated. So this was highly theoretical. So what I want to do is make it a little bit more practical by looking at some actual Redux code. So I want to do another case study, this time of a very simple application, the counter application. There's two buttons, minus and plus, and a number in between them. When you click plus, the number increases. When you click minus, the number decreases. Very simple. So in Redux, it's common to define all of your actions as const definitions. So what we see here, we have two actions, increment counter and decrement counter. And then we have these two functions, increment counter and decrement counter. And these are what Redux calls action creator functions. They create actions that we can send to the store. And an action is always an object which has a type property. And the type property identifies the action. So in this case, whenever we call the increment counter function, we get a simple object back saying which type of action it is. So now that we have defined our actions, we can take the next step and we can see how we can create a store. So what we do first is we set the initial count to 0. The counter starts counting at 0. And then we do a little bit of Redux magic. We say Redux create store. And as a second argument, it takes our initial count. And as a first argument, it takes this counter app function. So what is this counter app function? Well, that's called a reducer. And a reducer is a function which takes the old state and an action to apply to that state. And there are a couple of rules with the reducer. The first rule is that a reducer must be pure. So that means that we can never manipulate the old state directly. We always need to create a new copy. And the second rule is that whenever you encounter an action that you don't know, you simply return the state. So, and in the reducer, we handle our two action types, increment counter and decrement counter. So whenever we encounter increment, we simply add 1. When we encounter decrement, we decrease it by 1. So for example, if our counter app has a state of 5 and we send the increment action, it will be 5 plus 1. So 6 will be the new state. And this is a very simple Redux application. Redux is also framework agnostic. So you can use Redux in both React or Angular or any other type of framework. But it's more geared toward React, to be honest. So this was a very, very simple application where the state was an integer. That's not very fun. So I want to make it a little bit more complex, this time by adding the possibility of dynamically adding counters and dynamically removing them. So the code doesn't fit all on one slide. So what I did is, for each action that there is, I created a separate slide. So I want to do the remove counter first. But let's take a look at the initial state. So this time, it's not a number, it's an object. And this object has two properties. A next counter ID, which you can kind of think of as an auto increment ID on an SQL table. It's meant to increase each time a new counter is added, so we have a unique key. And the second property is called counters, which is a key value pair in which the key is the ID of the counter, which points to the counter object. And in this case, we have a single counter object which starts at 42. So then we see the remove counter action creator, but this one is a little different. This one takes an argument, the counter. And that's the counter that we want to remove. So basically, when you have these actions, you always have a type property, but you can add as many other properties as you need for your action. And in this case, it's just the counter. And then somewhere inside the reducer, we have the remove counter. And there I do this little trick with object assign to create a copy of the current state. Because remember, we cannot manipulate the existing state. And then we simply take the counter from the action and we delete the key in the key value pair map. And then we return the state and then we have removed the counter. So in this case, if we call remove counter with 1, then the count 42 will be removed. Then we have create counter. And it does not have a parameter because we don't know which counter we are going to create beforehand. And in the reducer, again, we create a copy. And then we increment that next counter ID manually so that the next time we also have a unique ID. And then we simply take that previous ID and assign it to a new counter object, which starts counting at 0. And it also knows which counter it is because it has the counter key stored in it. Then we have increment counter, which we also need to give a counter ID in the action creator so we can identify which counter we need to increase. Again, we copy the state and we pluck the counter from the initial state and we increment it by 1. Decrement is much the same, except it decrements the count by 1. So what we see here is an example of a more complex Redux application. And as you can see, it's customary to put your state in these objects, in this case, initial state. And for those of you who think, well, that if we have many actions, this switch statement will get really, really huge, and that's true. But unfortunately, we can create multiple reducers for the same application. So we can split it up based on the domain entity that we are going to manipulate. So don't worry about that. So the benefits of Redux is having a very clear answer where to put the state and how to communicate with components. But there are also a couple of other benefits. And the first benefit is that Redux makes universal JavaScript easier. Universal JavaScript is the art of rendering your application on a Node.js server and sending that back to the browser, which has CEO benefits and makes your application render faster. And the reason why it's easier in Redux is because
all of your state is located inside of a single variable. So you only need to set that variable once, and then give that to your component tree, and then you get your UI, and you can send it back to the browser. So if we contrast that with having state located in multiple separate components, we will have to do a lot of work just to get those components and assign the state correctly. So you have to write a lot more boilerplate code. So that's the first benefit. The second benefit is that Redux has a surprisingly good developer experience story. So GIFs say more than 1,000 words. So what we see here is another counter example, but this time with the development tools displayed on the right. So what we see here is that each time that we perform an action, we see on the right in the black bar, we see that action occur. And we can even click on those actions to pretend that they never happened. So that's really cool. What you can also do is you can commit states, and you can also load external states from JSON. So if your customer says, hey, I found a bug in your application, you could ask them to send the current state, and you can load it in your local development environment and see exactly what they saw. So that's pretty neat. Nothing is perfect, however, and Redux is no different. So there are a couple of downsides to Redux, and the first one is that it has a slight learning curve. You have to learn about reducers, pure functions, immutability, thunks, sagas. It's a very large framework. It's not that difficult to learn, but there is a slight learning curve. The second con is a little bit more insidious, and that has to do that JavaScript is not immutable by nature. So JavaScript allows you to change variables. So if you, by accident, do something in your reducer that accidentally changes the state, then your whole application will fall down like a house of cards, because Redux does not accept you mutating the state. So you have to be really disciplined when writing your reducers to make sure that you don't accidentally manipulate state. Luckily, there are libraries. This one is IMMUTABLE.js, also by Facebook, which gives you an immutable collections library. So in this case, we have this map and list. They represent objects and arrays. And whenever you perform an action on map or on list, you always get a new copy. And you never modify the existing object. So you can use IMMUTABLE.js to mitigate this weakness a little bit. But again, using this library, you create a little overhead. And if you have to communicate with some third-party library which expects normal objects, then you will have to do some plumbing to give those third-party libraries normal objects instead of immutable maps or immutable lists. So that was Redux, which gave us two nice ways to mitigate the two weaknesses of the component library. And now it's time to take a look at reactive programming. And reactive programming you can use to supercharge your components' asynchronous event handling. It's really powerful for that. So what is this reactive programming thing? Defining reactive programming, it's often easiest to look at what we call normal programming first. And in the reactive community, they call it passive programming. And what passive programming is that when you have two components, one component is in charge of another component. So in this case, we have a car and we have an engine. And the engine starts whenever the car key is turned. So in a sense, the engine component is not in control of its own destiny. It always gets told when to start. And in code, you can see it like this. So the car object has an engine property, and it fires up the engine whenever the key is turned. So reactive programming inverses this relationship. So in reactive programming, the engine knows when it fires up, and the car does not know that it manipulates the engine. And in this case, it does so via a callback mechanism. So whenever the car onKeyTurned event is triggered, the engine fires itself up. And this maps really nicely to our component to the benefits of components. Because if you write your component reactively, your component is in control of its own destiny, and you can really easily understand how your component reacts just by looking at the component source, because it will tell you in its source when it gets triggered, manipulated, or does some action. So callbacks are a very poor mechanism. They are relatively low level. So there are libraries out there, such as RxJS, which soup up this callback mechanism to make it more powerful. So RxJS comes from a library of families called ReactiveX. And what ReactiveX is kind of like a protocol description. So it's a big description of all of these kinds of operations and functions and methods. And then what they did is they created multiple implementations in multiple different languages. So there's a C# RxJS, there's one for JavaScript, one for Scala, one for Java, etc., etc. So just by learning one set of operations and rules, you can port that knowledge to various other languages. So what are the main concepts behind RxJS? The first concept is an observable, and that is something you can listen to. That could be anything: keyboard clicks, mouse events, AJAX requests coming in, WebSockets sending data over the line. Anything you can listen to, you can turn into an observable in RxJS. And the second concept is that of operations. And an operation allows you to manipulate your observables. So you can basically perform an operation on an observable and get a new observable out. So to demonstrate how operations and observables work, I've created this pseudocode example. And what you see here on this slide is an observable called A, which is an array of stringed numbers. So the numbers 1 to 10 in string form. So we can do operations on that stream, on that observable. For example, toNumber. And what toNumber does, it simply takes the string number and turns it into an integer number. But the reactive part is that whenever observable A changes, so for example, if we add the string number 2 at the end, observable B will also get updated and will get the number 2 appended at the end. So it reacts to changes on observable A. So we can do more operations. We can, for example, do an even operation, which filters the set to only include the even numbers. And again, it's reactive. So if A changes, B will get updated. If B gets updated, C will get updated. And we can do one final operation called aggregate, which counts up the even numbers in this case. So what I think is the beauty of reactive programming is that you can define D, and you know that it will get updated whenever its inputs change. And you don't have to do that manually yourself anymore. So that's pretty powerful. So to run it down through completely, if we add the string number 2 at the A observable, B will get the number 2 appended at the end. Then C will also get the number 2 because it's an even number. And then the aggregate will be 32. So it's very powerful stuff. So now I want to move from the pseudocode into the real RxJS code. And what I want to do is I want to take do another case study, and this time look at an autocomplete example. So everyone knows what an autocomplete does. You type in a query in a search box. It sends it to the backend, and the backend will provide you with suggestions. So in this case, we search for American, and it will give you some shows that start with American. The autocomplete is a surprisingly difficult thing to get completely right. So what I want to do first is I want to show you guys an imperfect example of an autocomplete, and then I want to improve it bit by bit using RxJS. So here's the code. The first thing we need to do is we need to get a reference to an input element. In this case, the element in which you can do your query in. And then we do some RxJS magic. We create an observable for each time the input element has a key up event. So whenever the user starts typing in something, the observable will fire and we get events. But the events that we get are JavaScript events, which will tell you which key is active, if the shift key was pressed, and which key code was entered. But we're not really interested in that. So we perform a map operation to get the value of the target, which is the actual contents of the input element that we currently have when the event was fired. And then we do another map operation, and map is exactly the same as the ES5 map operation we have on arrays. It performs a function on an input. So in this case, what we're going to do is we're going to take that query and we're going to give it to the search function, which does an AJAX request to the backend. And the backend will give us, hopefully, some auto-completion results. And then at the bottom, we see this subscribe function. And subscribe you can kind of view as the endpoint of an observable. So whenever something changes, and we are subscribed, we go into that subscribe operator. And the subscribe operator has two functions as arguments. The first function is for whenever something went well, for when a successful thing happened. In this case, when the backend provided us with auto-completion results. And we also have, as a second function, the error, which gets called whenever an error occurred. So, for example, if the backend was unavailable or could not provide us with results. And whenever we get a successful auto-completion, we update the UI. And whenever it goes wrong, we just ignore it, because that was what we do with errors. And subscribe should remind you of promises. So a promise in JavaScript can only be resolved once, but an observable can be resolved many times. So sometimes on the web, you will see that they call observables promises ++, because they have a little bit of extra functionality on top of promises. And it's also very easy in RxJS to create an observable from a promise. There are functions for that. But like I said, this example is imperfect. There are a couple of things that go wrong if you put this code in production. And the first thing is this guy. So, very slow, yeah. So what you see here is the time and some queries that we send to the backend. But what I want to illustrate is that each time you type in a query, in this case I love GOTO, we send all permutations of that query to the backend. So what we basically created is a very convenient way to spam your own server. So basically what we want to do is we want to say only send the query to the backend if the user has stopped typing for a little while. That's what we want to do. So there's an operator for that. That operator is called Debounce. And what you see here on this screen is what RxJS and the Reactive X family of frameworks call a marble diagram. So what a marble diagram shows you is an input stream, the operation in the middle, in this case Debounce, and what the resulting stream would be if that operation was applied. So in this case, the top stream has 1, 2, 3, 4, 5, and 6 as events, but 2, 3, 4, and 5 are really close together. So what the resulting stream will do is it will filter out 2, 3, and 4, and it will only keep 5. So we can use this operator for our example to limit the amount of queries that we send by simply adding this debounce operator. And then we say 500, that means if the user stops typing for half a second, then we send it to the backend. And this way we prevent us from spamming our server. But we're not there yet. There's still another thing, is that if your query has very few characters, you often get a lot of results which are not really relevant for that user. So in this case, we only get good results if our query is bigger than 3 characters long. So what we want to do is, if the query is less than that, we just want to ignore those queries. And there's an operator for that as well. This one is called filter. And what filter does is it takes a predicate function, and the predicate function is a function which must return true or false based on an input. And in this case, it will, if the x is bigger than 10, it will allow them in. So that's why you can see that the numbers that are lower than 10 are simply ignored. So we can use that in our example by simply calling filter before we do the debounce. And we take the query and we just say only allow them in if the query length is bigger than 3. So now we've solved that problem. But of course, we're not out of the woods yet. There's another problem still. And that is that sometimes we send the same query twice in a row. And this can happen if the user presses the enter key. So what we see now is that there was a 5-second window between the first GOTO and the second GOTO query. And we all know that we probably don't have new results within a 5-second window. So what we want to do is we only want to query if the query has actually changed from before. And there's an operator for that as well. This one is called distinctUntilChanged. And what it does is it will only allow an event through if it's different from the one before. And this is something we haven't seen before. What we see here is an operator which has an internal state. This operator keeps track of the previous entry that was made to it. So you can have operators that have state. So that's pretty powerful. And as you can see, in the resulting stream, we only have alternating values. So we apply this operator, distinctUntilChanged, and now we only send the query if the query has actually changed. So now we were almost finished. We have one big problem still left to resolve. And that problem is rather devious, and that's this one. So here we see a timeline, and we see 2 queries. So the user searched for GOTO Rotterdam, quickly realized that the GOTO is not in Rotterdam but in Amsterdam, so he changed his query to GOTO Amsterdam. But now we have 2 asynchronous requests in the air at the same time. And if your server is having an off day, the result for GOTO Amsterdam might get resolved first before the results of GOTO Rotterdam. So what you see is something very strange. Is in your query box you see GOTO Amsterdam, but you see the results for GOTO Rotterdam in your autocomplete, which is very weird and not something that we want to have. So what we want to do is we want to express the idea of only using the results of the last AJAX request that was sent to the backend. So as you probably guessed by now, there's an operator for that. Has a very strange name. It's called flatMapLatest. Don't ask me why. But it does exactly what I just described. So if you have multiple asynchronous requests, it will only use the results of the last request that was made. So that bug that we just saw is no longer an issue. So this is the completed example. And as you might notice, it's relatively small. It has a few lines of code, but it does a lot of work. And that's the power of RxJS. By using these standard operations and combining them in clever ways, you get a really powerful mechanism. And if I'm absolutely honest, if I had to write this without RxJS in pure JavaScript, my code would probably 500 lines long, and there would be probably a lot of bugs in that code as well. So by standing on the shoulders of giants, in this case RxJS, you can leverage them to accomplish great things in relatively few lines of code. But there are some other benefits of RxJS. And the first benefit is that the producer and the consumer are decoupled. So what I mean by that is that the producer in this case was the key up event that fired the initial event, and the consumer was the subscribe. And as long as the subscribe got its array of autocompletions, it was happy. So it didn't care how many operations we put in between there. We did not have to change the consumer or the producer. We didn't have to change that code. So that's very powerful. And of course, the other benefit, I already explained it a little, is that operations are a very, very powerful building block. So you can combine them in multiple interesting ways, again, like Lego blocks, and you can get really powerful results. But there is a really big drawback to RxJS, and that is that it has a very, very steep learning curve. And I don't like to call it a learning curve. I like to call it a learning cliff. Because this black one, that's kind of my experience with RxJS. And that's because you really have to let go of your imperative model. Because you are so used to always manipulating variables and not thinking in streams, that it takes a little while before that clicks in your head. But once it does, it's very rewarding, because you see a lot of problems that you would previously solve with imperative programming that you can now solve with observables in a cleaner way. So it's definitely worth looking at it. And as you saw from the autocomplete example, it's really, really powerful. The second con is that the documentation is very highly conceptual. And what I mean by that is that sometimes the documentation reads like someone's thesis project. It's really very high and abstract. So in this case, returns an observable sequence that contains only distinct contiguous elements according to the key selector and comparer. So what's a key selector? What's a comparer? Contiguous elements. So does anyone have a clue what this operator is? The description for this operator? Yeah, exactly. This is distinctUntilChanged. So sometimes when I'm trying to program in RxJS and I encounter this documentation, I'm like, oh, this is not the one I need. And then later on, I find something on Stack Overflow, then it turns out I had the right one all along, but this documentation doesn't help. And the documentation is also it shows you very non-practical examples. So it will always be like an array of 1 to 10 and then applies the operation on that. So it's not always practical. So what I wish that they would do is that they would use more practical examples in the documentation. So that was reactive programming. A nice tool to supercharge your asynchronous events. And that brings me, now we're almost at the end of the presentation, but it's customary for a presenter to give you guys some recommendations on how to use these technologies. And my first recommendation might be a little counterintuitive, but I don't recommend using Redux or RxJS if your app is really, really small, because you add a lot of overhead and that might not be worth it. So for the to-do application and for the counter application, using RxJS or Redux, it's really, really an overkill. But if your application starts to feel too big, and I know this is a little wishy-washy feeling thingy, but you know when you get there. So suddenly you will have this application and all of a sudden it won't fit in your head, you don't know where the state should be, and new team members don't understand where everything goes, then it might be a good time to start using Redux. Like I said, it has a small learning curve, but it's small enough so you can onboard new team members relatively quickly. So that's my second recommendation. If it starts feeling too big, just use Redux. It's a nice way to store your state. My third recommendation is that when you have events that require a lot of coordination, like we saw in the autocomplete example, you want to do some higher level things with asynchronous events, you want to supercharge a component, then it might be time to swallow the red pill and start using RxJS. But like I said, it has a very steep learning curve, so do expect some onboarding problems with newer developers, because you have to take some time to explain how it works and how to use RxJS. So I just gave you like a 50-minute-ish presentation on Redux and reactive programming, and I barely scratched the surface, so it's not enough to know Redux or RxJS. So what I want to do is I want to write a series of blog posts to fleshing out these topics a little more, provide you guys with some videos, with blog posts, to show you guys how to learn Redux and ReactiveX. The funny thing about both Redux and ReactiveX, there are a lot of videos available. The maker of Redux has his own course on Egghead.io. It's free, you can follow that, and he will explain how to build Redux and how to use Redux. So it's very cool. So keep an eye on don'tpanic.42.nl for that series, and I will start sending them out weekly starting this Thursday. So that's almost it. We also have a stand downstairs where you can play a Fallout-based terminal hacking minigame, and you can win a grand prize, a big rubber duck. And I'm also there at the stand, so if you want to talk to me about Redux or RxJS or reactive programming, come find me. So that's it. Don't forget to vote for this session and any other session that you attend. Thank you. Yeah, so there's a question, if the state gets really, really, really big, what does the performance do with Redux? Well, It will degrade, of course, because you cannot keep infinitely a number of things in memory. But if you use pagination or you only put in the store what you currently need, then you can mitigate that. It's regular JavaScript, so you can't keep putting in memory, and of course it will lose a little bit of performance. Okay. Memory leaks in Redux. I don't think that's something you can easily do it because the Redux there's one Redux store per application, so it's not prone to leaking because there's only one store, and that store will just need to be removed when the user closes its tab. So in that way, memory leaks are not that much of a problem in Redux because there's just one store and it will get cleaned up when you close your tab. So yeah. Yeah, so to give you guys a little bit background, model view controller versus the component architecture. So I did not invent the component architecture. I was really hit in the face with it. So we are an Angular shop at 42, Angular 1.0, and in Angular 2.0 they went to this new architecture. So, but the thing is, the trend has been going for a little while. So React was the first one to embrace the component architecture. And Angular followed suit, and Polymer came along. So a lot of frameworks are moving towards components. So I think that if you upgrade to Angular 2, you don't have a choice. You will go to the component architecture. But the difference between the component and model view controller, it's just that in the component, it's basically the combination of a view and a controller in one single thing. But the difference is that it does not try to take them separately. So with model view controller, there's often a lot of talk about having multiple controllers for the same view and having multiple views for the same controller. And we all know that that's secretly not true. I've never written a controller for multiple views or had a view for one single controller. So really the components are basically a way of saying we acknowledge the fact that they are married to each other. So let's not pretend anymore that they are two separate entities. So it's not too much of a stretch to migrate. And in Angular 2, there are upgrade guides on how to do that. So,
Thank you all. Thank you very much.
Yep.
Thank you, Maarten.
Yes.